Okay guys, so let us go straight to the rules. So to the rules, in this case I'm going to do the first step. In this video I'm going to do to change numbers from base 10 from the decimal numbers. I'm going to change numbers from decimal numbers. We'll see where to end, but we're still concentrating on our 4 systems. Base 10, base 2, base 8, and the hexadecimal, which is base 16. So okay, so now when dealing with base 10, what do we need to know? So okay, let me just go to the first one. Let's say changing from base 10 to base 2. Base 2 is binary. I hope you have not forgotten binary numbers. Changing from base 10 to binary numbers, from decimal to binary numbers. So how do you change numbers from base 10 to binary numbers or any other base? I can just do this one example, but I'll make sure that I do all of them so that we don't get lost anywhere. So changing numbers from base 10 to any other base, what we use is what is known as the ladder method. We use the ladder method. It is simple and straightforward. Actually, we use the ladder method, and if we have the point those numbers with points, we use what is known as the multiplication chain. So I'll show you how the multiplication chain works together with the ladder method. So in this case, let's focus on the ladder method. Ladder method. So the L method, ladder method. So example, e.g., let's say you're given a number, convert 53, which should be in base 10 to binary, or to a binary number. Okay, so how do you change, or how do you convert this 53 to a binary number? So don't forget, binary number is the one we are calling, or we used to call, base 2. So don't forget, it's one we used to call base 2. Okay, so I said that we're working with the ladder method. Ladder method is the one I've been doing actually from grade 8. Is the one I've been doing, if it's grade 8 or grade 5, wherever you started this, whichever grade you touched this topic. So changing from binary to, changing from this 53 to binary. So we're using the ladder method. How does a ladder look like? A ladder is something that should have 2, I don't know if you can call them 2 bars. 2 bars, which are 2 long bars, and the other bars, which are mostly horizontal, they're short and they cut through the long 2 bars. So this bar, what does it tell us? The bar tells us that this first box contains the bases. The base. This is where the base sit. Which base are we talking about? The base we are changing to. The base we are changing to. So in this case, the binary base, or base 2, will sit here. Will sit in this column. And then here, the middle column is where we write the quotient. Don't be confused with what the quotient is. The quotient in this case is a number that we get after dividing. It's called the quotient, the baby, or the result of the result of dividing numbers. So let's write Q here. Don't worry, I'll explain it, or you will know what it means and how it works there. So the last one is where we have remainder, because every number that we divide always gives a remainder. Every number always gives a remainder. Just stick to that. There's no number that doesn't leave a remainder. Every number leaves a remainder. You'll know why we say that, or why I've said that. Okay, so we have the BQR. Okay, so this is the ladder. So our quotient in this case, we had 53. 53. This number becomes our quotient. So you take it as your quotient. You write it 53. So this game we're going to play now is a game of dividing the 2 into the quotient. Always you are dividing the base and the quotient, the base and quotient. That's why you can also call this the division chain. If you don't mind, you can also call it the division chain. So how does this work? The ladder method would tell you that you just get the 2 divide into 5. 2 can divide into 5 2 times, giving you a remainder of 1. But don't forget, 5 is not our number, but 53. So that 1, we're going to add it to, or we're going to put it with the 3, giving us 13. So 2 into 13, that is about, isn't it 6? 6, giving us a remainder of 1. That 1, we write it in the remainder, because we're done with the 3 and the 5 and the 3. So the 1, we write it here. And then here we bring back the base. We're still in base 2. We're not changing the base. We do the same thing. 2 into 2, it is 1. 2 into 16, it is 3. Yes, it is 3. And then in this case, I'm sure somebody is going to say that there's no remainder. 2 can enter into 3 without leaving a remainder. There's a remainder, guys. The remainder is 0. Everything always gives a remainder. And in this case, 0 is a number. Although they say 0 means nothing, but it's still a number. Yeah. So we bring what? We bring the 2 down again. That is only for the 2. This column is the simplest column ever you find in life. But everything is simple, guys. Come on. So 2 into 1, it can't. So we just have to do 2 into 13. And if you check properly, here where we did 2 into 13 to give us this 6. So we know that 2 into 13 will give us 6. And the remainder of 1. So our aim is to make sure that this number tends, or the quotient tends to be 0. That's where we end. That's the rule. We should make sure that our quotient becomes 0. The ladder should start from 0. Don't forget, when you're climbing the ladder, if we're counting the distances, and if it's physics, we're counting the distance, we always say that you start from 0, the distance from up to down. You start from 0 and then you start climbing. You're now counting 2 meters, 3 meters. In that case, we have to make sure that our the ladder or the quotient gives us 0. That way we'll be satisfied. Okay. Let's continue. So in this case, we'll repeat the 2. 2 into 6 is 3 times. 3 remainder 0. And then 2 into 3, it is 1. 1 remainder 1. 2 into 1. 2 cannot go into 1 in this case. 2 cannot go into 1. So that leaves us a remainder of what? Oh, that gives us a 0, because it cannot. When you say it can't, well, meaning 0. So it cannot go into 1, and meaning what are we going to remain with? We still have the same 1. So the same 1 becomes our remainder. So in this case, we have this. What do we have here? This is our, we're done. This is the ladder method. You start from 0, you climb up. You're climbing up to 53. It's like you're asking yourself, how did you reach to 53? Yeah, it's the simplest method ever, guys. Yeah. So in this case, our answer, don't forget, as I said earlier, we're starting from 0 going up so meaning our answer is the remainder. The remainder is always our answer. We're getting it from down going up. Don't forget, I said it's a ladder, and the ladder we climb from up going, from down going up, sorry. Yeah, is it called descending order or ascending order? Ascending, going up. So our answer becomes, our answer in this case becomes, our answer becomes 110101. 110101. Don't forget it's base 2. But I think, and if you don't write, they will know. But just to make sure that nobody says that why haven't you written with the kind of base we're in. So we just write a subscript, a comma small, letter 2 down there. Number 2, sorry, at letter 2. So that is our answer if you're changing numbers from base 10 to base 2, which is known as from decimal numbers to binary number. You have it.